refresh the. Wait, okay, that's cool. There's nothing in because I haven't plugged in. Cool. All right. Cool. Thanks a lot. I got it. Thank you, Alex. This room's fancy. The camera in the back. So I just plug in and everything works. Unlike the other boardroom where I have to just. And front classroom where yesterday has it. Here's that I'm connected to an Apple TV. I want to be. Laptop. Hey, that's my laptop. Hey. Cool. So, how's everyone doing? How's the day's assignment? Good. What's everyone been working on? But you completed it. That's the important thing. Completion is part of what you're evaluated on. So is it working in a way that's kind of like, okay, I didn't do it that way, but that's good enough, or I did it completely wrong, I should redo the whole thing? Okay. Oh, but you got there. Instructions make it hard. Okay, so the two-player math game. What's the other one even work? Boxes? One's finished boxes? Okay. Bring up. So you have boxes math game out in content. Part 1. Part 2. Alright. A week now. That's a new feature. Okay, so what I wanted to talk about, what we didn't get to this morning, and the purpose of this breakout, I believe, look at the breakout, is let's talk about initializers and custom initializers, which just happens to be on my things as well. Initializers and custom initializers, class methods over instance methods. This didn't really talk about pointer. I guess we kind of spoke about this. Yeah, we talked about that a lot. So maybe. Yeah. Like that? Yep, that's how you would check for equality with string. Two. Other objects have, I don't know, object is equal to. I think it's just that. Other. So these are kind of the three ways you can compare objects. You have the double equals, which is memory address. You have is equal to, which exists on NS object, and so every other object gets it. If you create a custom object, you would override the and you would, person, if they have an equal age, that's good enough to be equal, or maybe two people can have the same name and age and be different. So you have to figure out another way. That's kind of like up to the object. Like, how do you equality? What does it mean? And then some objects go even further, and checking is equal within an NS string doesn't check for the string equality. It checks if, I'm not sure what this does in NS string, but to check just the character representation, you would check is equal. So some have custom things, some objects have further custom. Yeah, exactly. So let's say we have a milkshake, and we want to, how do you check if two milkshakes are equal? Or maybe it's how many boys in the yard they've got, right? So you override is equal to be that, and then you check to them. So this is custom equality. It's like, what does it mean? Well, the string, the characters have to be the same memory address. Is better than. Once we get to Swift, you can do custom operators, and that's a whole. I guess it would be, is better than is great. It is. Milkshake is better than. You just create a custom method. Yeah. It conforms to the subjective protocols and. So we're gonna go from 3:30 to around 4:30, depending on how we're feeling. We have the room till like 5 on it. I want to go over initializers, custom initializers, and class methods. But if you guys want to go over anything else, and we can chat about anything. But yeah, let's look at initializers. So this morning we had the milkshake class, and we have two properties: thickness and is better than yours. Now in main.m, when we want to set is thickness and right here. We have to do it this way, line by line. Create a new milkshake, set this property, then set this property, and then do whatever we want. There's kind of like 3 steps here. Initialize the object, set some properties, then do something. And this is pretty common. We usually want to set up an object with some default values. So we set up the values this way, and then we perform some action at a later point. Custom initializers, which we've already seen, help find the initialization of an object plus setting the standard values, not default, but the initial values for objects that you want. So this is kind of a perfect opportunity for Milkshake to have a custom initializer. So let's create one. How do we create a custom initializer? What is a Yeah, init with. So a custom initializer, you've seen them. They're init with. We've used it with strings or arrays. Yeah. Those are the steps we're trying to achieve. But what is an initializer? And it does the initial sets up the initial values, like sets up the initial state of the object. So if we wanted to, let's just say, override the default initializer, we could do that the same way we'd override any method because we're subclassing. We're getting a little bit into subclassing now, but we're subclassing NSObject. NSObject has an init method, so we can just override that by implementing it. So instance type init, and then what's the code that goes in? What is instance type? You can tell me. Okay, so we know we return self, and we know the instance type has to match the return type. So what is the type of self? What's its type? Milkshake is its type. So what is instance type? Milkshake. default that you can put in there, and Objective-C will figure out. If I mean instance type, I mean the type that is in this object. An instance method, so the type of object that has the instance type. Before instance type came along, I think it was Objective-C. Around the time of like iOS 4 maybe, or 5. Before that, we had to use ID if we wanted like a general initializer, because yeah. The cool thing about this is that let's say we put in milkshake. That means that if we subclassed milk, the initializer would be overriding the milkshake in it, and it would expect to return a milkshake even though it's subclass. So it's actually, I don't know, strawberry milk, but it still returns like this superclass thing. Whereas if we use instance type and we subclass milkshake to strawberry milkshake, the initializer will return a strawberry milkshake. So you want to go down this route of using instance type instead of hard coding milkshake in there, but it is returning milkshake. So I just wrote my initializer here like that. If I type init in Xcode, it'll say something like this, Objective-C init method, which is a code snippet. If I press enter, that is the whole initializer, everything, which is way easier than having to type all of this and memorize what the code is. So if you're going to put some setup code in an object, just type in it, hit enter. You can also find code snippets in the right-hand panel. This little icon here, code snippets. You can search for pretty much anything, but if I search init, oh wow, this is C++, Objective-C init method, and I can literally just drag this code snippet into my code, same thing. Kind of cool thing to explore, like see which different methods you have that Objective-C just, or that Xcode just gives you. Okay, so my init. So this is overriding the default initializer. This is what gets called. Well, to be honest, like nothing special really happens about with the init. We are calling it like any other method. Where are we calling it? Oh, right here. We're just calling it, right? We are manually calling init, so we can tell that, all right, we're going to call init, this is run. So this will get run as soon as we create the object. We allocate it and we init. All right? Yeah? Okay, so what is super? Okay, so do we need to call super in it if we override in it? So if we didn't call this, what would happen? Exactly. So you need to call this to have the superclass do all of its initialization. When NSObject initializes, we need to store all the values in self. It returns the type, so return NSObject, or in this case, a milk. So we store that in self. This is kind of weird, and I swear this is the only language I've ever seen this in. When is self not going to be valid? Like if the initializer really messed up, and when an NSObject initializes itself, it should never mess up. So this should always be fine. This code should always fire, and you know it's kind of a weird language the way it handles some things. Yeah, if you took this out, this would work like 99.99999%. Best practices in case the initializer fails. Exactly. So it's like, yeah, but this is how it's done in a. I mean, yeah, it should be something. I don't know. I don't know what you do. Failed. Kind of screwed anyway. Yep. Do everything in the superclass, which you always want to do. If you override a method, call super. Yeah. Unless you have a good reason not to, always do super anything. Override a method. You know, if we create strawberry milkshake and we override bring to yard, we're probably going to want to call super bring to yard, unless we have a good reason. Right, so we have this. So in here, we can put any code, any setup code, like, you know, create some default values. So what might we want our default values to be in here? We have thickness and, yeah, thickness and is better than yours. Default values for thickness. Good default and is better than yours? Defaults to no. Okay, cool. So we're being explicit about what it defaults to. That's cool. Everyone happy with that? All right. So now, I don't know if we're actually printing stuff out here. Yeah. Okay, so milkshake 2 will now have a thickness of 5 if we're putting that out anywhere. I don't think we are. What was the last thing we were? Oh, right, these primitive types. Let's come. Okay. So we milkshake 1 we're changing the values, but milkshake 2 will have the default values. Let's just let's charge what? I don't know. Bring to yard. Ugh. All right, let's just print out the values. This is getting. So like milkshake 2. Thickness is going to be an int. Shake 2 dot thickness and an s log. Just do the thickness for now. Both the milkshake 1. Okay. So we'll print those out. Last things we print out so we can get rid of everything else. Cool. Okay, so milkshake 2 has a thickness of 5, milkshake 1 thickness of 7. Because the default value is 5, but that's not going to stop milkshake from setting it after it's been. The first thing that happens, as soon as init gets called, those values get set, and then we can set them different things. Yes, or is better than yours. We could do that. But let's not subclass just yet. Let's create a custom initializer. So I want to be able to set these values when I do the init. So we know we want to create init with. So let's see. What's init with going to return? Instance type. And then init with. Is there anything special about init with? Does that do something special for the compiler, or does it just different name? It's just naming stuff. So init with, what are we going to init with? Thickness. Okay. Thickness. Because this is a parameter, that's the first parameter in the method. Then what? And betterness, bool. I'm just going to call this better. Yes. There's nothing really super special going on. It's just a method, right? Not in here, not unless we call it, because it's just a method. I mean, I could, to make it maybe more explicit, I could just call this, I don't know, setup with thickness, right? If I don't call it init, is it an initializer? Well, if we treat it like an initializer, yeah. But we'd have to put like init code in here. Right. This one, yeah. Does super automatically get called when you have other methods? Like if I create, in here is super anything getting called when I call bring to yard. So why would super get called on this method? Yeah. So with when we create a custom initializer, we're just creating a method. So nothing special, no super in it will get called within that. If we use this as an initializer, we will have to call superinit. If we don't use this as an initializer, superinit will get called because init will just. So if we don't call init, if we call something else that handles our initializer, like init with something, we're going to have to call superinit ourselves. Or call init. But usually it goes the other way around. Like in the custom one. So, yeah. I'm going to rename this to init. But no, we're going to have to do everything ourselves. So if we're now treating this as a designated initializer, which is one of the technical terms, designated initializer means other initializers are going to point to it, we're going to have to call superinit. What I'm actually going to do is take all of this code out of here and paste it into here. So that does the call to superinit, which sets up all the default values for self that NSObject is going to do. Then if self, we're going to do some custom stuff. Here, we're actually going to set thickness to be thickness and is better than yours to better. And then we're going to return self. So all of that stuff is going on in here, which means that in my just standard initializer, I could do this. Return self init with thickness 5 and betterness no. To a designated custom initializer now, which does the call to superinit. At some point, an initializer has to call superinit. But you put that in the designated initializer, and yeah, you make sure that you call that one. So superinit is still getting called. We're still just doing the same thing that we did before, but we now have parameters that we can use, and this one is going to use this method here because convenient. We're going to write less code that way. But we can now open this up to the rest of our code. So if I throw this in the .h, the rest of our code can use this custom initializer. If I go to main, instead, milkshake 1, we're going to leave, no, milkshake 2 we're going to leave alone. Milkshake 1 we're going to init with thickness 7 and betterness yes. And now I can delete these because those values are set up. So the point of the custom initializer there was to really make our code smaller, like reduce the amount of lines we have to write because yeah, that's always nice. It's to group the things that make sense to be grouped together. So in this case, default values make sense to be grouped into the initialization method. Yeah. Grow it as you need to. Don't overcomplicate it, exactly. But as I've been saying a couple times, an initializer is still just a method. So you would never do this, but you could do this init with thickness, right? It's just a method you can call on milk. It happens to be a special kind of method. We treat it in a special way. We only call it the first time we allocate it and never again. But it's just a method, so we treat it as a method. It takes parameters just like any other method. It has a return type just like any other method. The return type's a little bit special, but that's it. It's just a method. So, and we have to call super, but because it's just a method, we have to do this. There's nothing special about this method. That's why we have to call. Other languages, you'll see there is actually special constructors and things like that. This is just a naming we give to methods that we're going to use as custom constructors. Exactly. By default, it will just use the superclasses in it. Yeah. What does NSObject do in its init? Init, NSObject. An object, what's it going to tell us? Implemented by a subclass, description. Yeah, see here. an initialized object, this is what it returns. This is why we have to do if self, or nil if the object cannot be created for some reason that would not result in an exception. Like even their description is like for some reason that would not result anyway. Ugh. Yeah, exactly. I mean, Objective-C you kind of have to be. It's just loosey-goosey. An object is not ready to be used until it's been initialized. Keep that in mind. In custom implementation, it doesn't really say what it does. Yeah. It just says do it, and if you're going to override it, do it this way. But that's it. So I don't know. Give it a Google. There'll be some stuff out there on the internet. But as far as like how much should we be concerned about that? Apparently not much. It just does stuff, and we have to make sure that we call it. Oh yeah, absolutely, every time. Otherwise, your code will just not work. Yeah, so a custom initializer calls superinit, or either directly or indirectly. So in this case, we're calling superinit directly. Great. This case, we're calling it indirectly by calling another initializer that calls. At some point, superinit must be. You wouldn't want to do something like this, because then it's getting called twice. So make sure that you're just calling it once. Okay, any questions on the custom initializer? No? Everything making sense with that? Just a method that you implement, return type, and parameters. And this is obviously how you do more than one parameter. This is 2 parameters. Yeah, yes, the default, the designated initializer. If you're doing object-oriented programming correctly and your object kind of has its single reason to exist, takes care of its one thing, you'll find that every time you'll mostly just have one designated initializer. So I could create even more in here. You know, you can create maybe a person object that has a name and an age, but another initializer that also sets a social security number. And you'll find that no matter what, you'll always end up with one designated initializer, even if you're passing in nil for a bunch of values. So there won't be many cases where you have like 5 custom initializers and there's no like order to get it to just. So yeah. I mean, hopefully you only have like you'll have a limited number of custom initializers because, like I said, you want to be able to create your object easily as that single reason. Probably just set the default values. That makes sense. Okay. Everyone happy with that? Custom initializers. So the next thing is class methods. Methods that exist on the class instead of the instance. Everything we've created so far, properties and methods with the minus sign, are instance properties. They exist on an instance. Create an instance, and then you can start using these things. But we can create these things called class methods. And a class method looks like this. Plus sign, return type, method name. What is our milkshake? What is every milkshake class instead of an instance? A little bit like what would we put here? Well, that would make sense for a single one, but not all of them. What do we put here? Yeah. Oh. No, the class being the class. It can be, but what else could we use? So we'll start with let's start with a kind of a weird one. We could say something like total milkshakes created. We're going to have this method. It exists on the milk, and we're going to ask it to tell us how many have been created. And the way we can do this, by the way, everything else is pretty much the way you would use a method. It's just the plus sign that makes it different. I'm going to return 0 to get rid of that warning. And actually, let's just try running it like that. So we've got this class method, total milkshakes created, it returns 0. So up here, before we create anything, let's just call milkshake total milkshakes created. Class method, you just call it on the class. And I'm going to ns log it. All right, so we'd expect this to be 0, and then we'd expect, as soon as they're created, for it to be 2. Have milkshakes keep track of the total created. So if we look down, we've got context here. I see those 2 zeros. I'm pretty sure those are values. Total milkshakes created, 0 and 0. Okay, that's kind of what we expected. But at least we have an idea of how the method, how we can use it. So do you have any ideas about how we could actually keep track of? Yeah, but I don't care if they're in memory or out of memory. I just want to know how many have been created ever. So it's a little bit simpler than that. We just need like a way to increment the variable. Yeah, so how do we create like this global variable? Maybe not a global variable, maybe just something that exists on the class milk. Yeah, class property, but those aren't real in Objective-C. What? Like hashtag defined. Those are macros that let's stay away from those for now. Static. Who's read static? Static int I don't know, milkshake. Milkshake. Wait, is milkshake one word or 2 words? So I've actually been doing something weird by camel casing this single word. Good job, Sam. Okay. Static in. All right. So so let's just look at this. What's going on here? Yeah. Yes. So what's the scope of milkshake? No curly braces. Created this static thing. We just kind of did it in the. The whole milkshake class. Yeah. So does it matter if I put it here or if I put it here or? It doesn't really matter. It will be linearly, like the code below milkshake count will only be able to use. But apart from that, it doesn't really matter where I put it. It doesn't really have a scope other than this .m file. Because I'm only using it really with this method, I'm going to kind of group these together so it reads a little better. But if we create a static in a .m file, it exists in that .m. But it doesn't exist globally. It doesn't exist to the rest of the code. So my main.m cannot access this unless I made it accessible to the page. This is not an Objective-C thing. This is an object thing. This isn't a class thing. This is .m file. In the .m file, you can create static variables that exist, and then you have to expose them in the .h. So if I take milkshake count and I return that here, and then I just increment it in every initialization. So I don't know, if self, let's plus at the end or at the beginning. Doesn't matter. So Do we expect this to work? Do I need to get it? So I don't want to actually give. Do I want to be able to pull it? So you got to think of what is the purpose of this variable. This purpose of this variable is to be incremented every time initialized. So being able to return it in a method, like total milkshakes created, that makes sense because we want to be able to read the value. But if I expose this publicly, then people might be able to change it, which I don't want. I only want this code to be able to. So instead of exposing this, I'm going to have a class method, and also if I expose this in dot header, it wouldn't be a class property. It would just be. So yeah, all kinds of stuff. So we're kind of using weird like C things with an Objective-C class methods. You know, in the .m, some stuff's going on, but as far as we're concerned, in the .h and we just get to call total milkshake. So we've encapsulated the weird stuff in the .m, and we just get to use nice class method abstraction. Total created 0, total created 2. So that might be a reason that we create a class method. Do something like that. Information. Yeah. We create class methods, like NSString has the class method, NSString format. So you create a string. A new instance. Yeah. There isn't overriding, because, well, there's no original. Would take those two instances and a new instance. Yeah. The old one's still there. So that is something we can use class methods for, and it gets used pretty frequently. Kind of custom initialization, but at a class method level. Why might we want to do that? Why might we want to do custom initialize with a class method? We might want to access something like that while creating it. I mean, we could actually access that from everywhere else in our code, though. I mean, there's a few reasons, but one, well, let's just create one and we'll see maybe. So I'm going to create a custom initializer, the same initializer that this does, but I'm going to do it as a class method. So let's just paste that. And since it's not an official like initializer type method here, I'm going to remove it. And what's the naming convention when you create a new object? What are the class methods called? They start? Well, that's actually the instance. Let's take a look. Class method. Methods. Initializers. Swift. There we go. String returns an empty string, which is the same as init. Call NSString string, which will return an empty string, same as calling alloc init. So you just use the word, like the name of the class or the thing you're creating. Yeah, so we could do something like start out simple. Instead of doing this as a class method, let's try the normal one. So maybe in type milkshake, camel case string. And what do we expect milkshake to return? Well, just milkshake alloc init. So in the implementation, return self alloc init. So now we can, instead of doing alloc in it, I can say shake. And you'll see this used a lot. Same exact result, but I don't have to type in alloc in it. A lot of classes do this. NS string will create a brand new empty string, which is kind of pointless, but yeah. NS array. Kind of what the new method does. NS mutable array, mutable array. Oh, maybe it's array. Oh, right. But it does actually create a mutable. Yeah. So you have those, but they also have documentation. Okay. String with format. Creates a new string with format. Localized string. Location string. String with characters. String. Eight string. So a lot of the time you can do alloc init with string with init with UTF-8 string, or you just with UTF-8 string. Most of these start with the thing you're creating. If we create a custom initializer using the class method, it's very common to start the method with the thing you're creating. So in this case, our custom initializer would start with milk, shake, with thickness and betterness. And you can probably guess what this is going to look like. Turn self init alloc init with thickness is thickness and betterness. Okay. Cool. There's a lot of class methods that just do that. Yep. Shortcuts. Shake with thick. Cool. Now these aren't super helpful. Yeah, okay, it can be a little bit nicer to write this way sometimes, and it's good to know that these objects, because sometimes Apple gives you a convenient initializer as a class method, but if you didn't use the class method, you have to do alloc in it and set 5 properties underneath, 5 separate lines. So it's good to know that these exist, especially when we get into iOS, and there are certain things that do that. But yeah, you can create your own class methods that do these things, custom initialization in your object. Thought that I wanted to say, got it already. But how many times have I said? I've been saying convenience. Oh, okay. Just once. Convenience initializers are initializers that call designated. So what I've been meaning to say is custom initializers and methods. This would be considered a convenience initializer because it's an initializer that you. But we won't really get into that. It's more of a Swift thing anyway. When it becomes official and you get the convenience. Yeah. Oh, right, yes. Sometimes these are much more useful. Like if you wanted to concatenate 2 strings together in Objective-C, you can't just add them together with a plug. You have to concatenate them together using a method. So it kind of makes sense to have a class method on init string itself saying string with format, and you just concatenate one, right, in this kind of format. So this makes a lot of sense to create a new string from other strings, just to have that as a class. But that is, yeah, class methods. Sometimes you might just have a class that is full of class methods. I don't know, maybe create a new sort of like something you might want access to. The whole app. Or app, what would you, every class want access to? Settings. Okay, yeah, cool. That's actually pretty good. Settings. What's settings for jazz hands? What's a setting? Speed for jazz hands. What is speed? A double? Yeah. Speed. What else? Here, int. Number of hands. Sure, maybe. I don't know. Hand? Touch bar here. By the way, I'm this Apple. I've got the touch bar, and I never use the touch things for what they're intended to. I only ever accidentally put my display to sleep and other things. Number of hands. Maybe you'd want Azina or like I can't think of it. I don't know, other things. I've had it where I've set one up for like an advertising network and put all my advertising keys. Everything or some classes are going to need to access those keys, but I don't need to like. I just need a convenient place to put information. So if I just take these, it's kind of the object-oriented way of creating globally available variables. So I can just return. I don't know. How many hands? 4. Right? And it's as simple as that. Like I just have this settings object that holds this data. It's kind of global data, but it's not really, because if I need to access this employees, I just import my settings h, and maybe I have a method employees, or maybe write the initializer, and I can just say settings number of hands. And just anywhere in my code that I need this kind of settings data, I can just grab it that way. I don't need to create a new instance of the object. I just need it to exist somewhere. And this is a nice way of having it kind of namespace. I mean, even if the user didn't get to choose their font, let's say you wanted to use a font for your entire app, just a font, and all your code needs to have access to like what font you're going to use. Maybe you start a place so your entire app uses font. Maybe you have a background color for every screen. Store that in the settings where you can color. Stuff like that. And there's other ways of getting around that too, but yeah. A lot of the time it is initializations. But those are class methods. If you ever see a plus, class method, and they are much less common than normal methods. Methods are way more powerful, way more relevant to object-oriented programming. Kind of just creating functions. Yeah. Any questions about that? Those are initializers, custom initializers, and class methods. How do you get an object to return the name of its instance? So I think what you're saying is, let's say, right. So I'm a new whatever, and you just expect to be like milkshake2, like what's your like class name? Oh yeah, do you want like oh okay, and you want the variable name too? Well, I guess the variable name doesn't really make sense. But all right, let's see. So did you mean like yeah, you want that to print out milk, class milk? Ah, okay. So it, is this kind of like this, but you'd rather have a method do it? Like, hi, I'm a new milkshake and my name. Uh, so the actual instance and the space in memory and the like object is very, very different variable, and the object itself has no idea about the variable. Yeah, this is just a variable name, and like if you think about it, there's nothing stopping me from creating many points to it. So I don't know, milkshake hang equals milkshake two. So then it's like if the class was actually uh, keeping track of what its name. Maybe for this, or I mean, it doesn't. Well, yeah, there is like you probably. I'm not sure if there is a way of doing it. Probably, uh, but it's very pointless because the only way you would have a reference to that thing is if you had the exactly. It's like, oh, I'll just like put it in an array, but as soon as it's in the array, it's lost its variable name. So at that point, you're just talking about a variable name that has little to. Sure, that variable name is used to point to that space in memory, but the variable name is a variable that has nothing really apart from it. Yeah, okay, so you could do that. So you could do that. So let's say we have milkshake and we decide to give milkshake property name. Now, so add this to our initializer and bitterness. One single property and you got and name. Quicker and swift. Much quicker. Especially if you default name. Yeah, last step self dot. Cool. So now we can say with thickness 0, bitterness no, name, and now we have pancake and I am a new. And we could have called the name pancake or whatever I called it. Oh, right. Updated the custom initializer, which means I got to update every bit of code that uses that custom initializer. Okay, I'm a new milkshake and my name is Dad. So you can make a property, but you can go kind of one step further too. Like if I'm gonna well, if I wanted to log this out for a bunch of milk, just to prove a point, the names have nothing to do. Um, if you wanted to print this out a lot for each thing, maybe you'd actually want that to happen if you logged the object itself. So if I'm going to log out pancake, what do I want that to be? And what will happen by default? By default, it will give me the class name and the memory address. But what if I wanted it to say, every time I log out a pancake, the behavior of a milkshake is to say, I'm a new, and then the class type, and my name is. Uh-huh. It's its description. So if I override the description, void. Is it void? No, it's NS string. Description, and then return new string. And return this. Okay. Now run it. No, self not. Now run it. Now we can log out any milkshake, and it'll say, "I'm a new milkshake, and my name is," or my name is whatever the. So you can do kind of. Well, description is just an NS string. So description is a string, so I can return anything here. I'm using a format string, so I can add some. It's a method of NS object. Yeah. Now I'm overriding this from NS object. What do we do when we override methods? We need to do super. What would super init do? What would not super? What would super description do in this case? Okay, and what's NS objects and the class name? So this will return the default descriptions, but in a variable. Well, do we want to use the default description for it? If we don't want to use that, if we're just like, I don't care what that is, yeah, there's no reason to call super. It doesn't do anything other than return a string. So when it's a method like this, we don't have to call super, but we have access to it, and we can call one, which means that maybe we also want to log the description at the very beginning, and maybe a colon followed by like a new line followed by our custom description. So I'm just going to throw in the as the first thing. Now every time I log milkshake, I get NSObjects version, which is the memory address. Cool, nice information. And then a new line, and then I'm a milkshake and my name. Never. If you were comparing, like if you visually wanted to see, hey, is this the exact same place in memory? Oh no, this is 10 and this. But that's it. Yes, that's a use. So super, yeah, you can call when it's relevant, just know what super. If it does something, if it performs an action, the class needs to. If it just performs some sort of like getter action, then you kind of have the option. But yeah, the cool thing there is that like with NSLog on a milkshake. Cool. So we got milkshake. We can see that they're all at different memory addresses and they have different. My name is Noel. My name. So this is what NSString is doing. It is overriding description and printing out the characters. That's why we can NSLog a string like this. But this %@ just means log this object's description. Describe it however you want. Yeah, behind the scene it's saying that exactly that. But this looks log the object. Yeah, great for debugging and calling command line apps. Once we get to iOS development, is really something like that. Yeah. So if you want the object itself to contain the data, you're gonna have to give data. Contain in this case the name. Yeah. Oh, you could compare them. Well, that's kind of like a equal thing, and then you quality kind of stuff. Great and easy. Any other questions? Anything else you guys want to go over? Any pain today that are kind of blocking? Work twice as hard. Stop making mistakes. About it. You can do speed typing. Typing definitely, like typing fast helps. But oh wait, no, I have a tip. Plan on paper before you code, or a whiteboard or anything. Plan like when you're coding and you make a syntax error, you can't really error, but that isn't like the point. You just want to plan like the structure of your code. You want to plan what you're going to do. All right, I'm going to take an input string and I'm going to do this to it, manipulate it this way. But as soon as you get down to coding, you're like, oh, how does fgets work? Blocked. And you've got to think about how to write your code and what your app does at the same time. And our brains suck at doing well, any more than one thing at a time. So separate your tasks so you can do just one thing at a time. Plan on paper, then use that paper to write this in. You don't have to think about the logic. You've got the logic. So try and separate your things so you're only thinking. Don't context switch. Like flow and code. Don't like get a coffee and then around and then get a coffee. I don't know. You know, that kind of stuff, yeah. Yeah. So yeah, practice just planning out on a whiteboard or get a notebook. I use a notebook because I do a lot of my planning when I travel, bus or on a plane. If I'm planning with someone though, I always use a whiteboard. Yeah. Yeah. So there you go. So you know, use the learning techniques you always use. Learn through technique, practice, blog posts, whatever. Yeah, use them. The writing of the code is only. All right. Any other questions? Anything else? Oh, all right. Cool. I'll let you guys get back to it. And oh, you have a different lecture tomorrow. Cool. Same room, same time, every day. Like say 9 a.m. But it will be. Yeah.